So today I'll be talking about how remote sensing can play a role in deforestation. Budget version. So what is deforestation? Deforestation is a kind of activity that involves the removal of a wide area of trees or forests, where the land is thereafter converted to non-forest use. So someone comes along, and then they want to remove these trees from the land, like so, and then they use the land for something else, such as housing, or they could use it for agriculture. Deforestation can have many adverse effects. A large number of plant and animal species live in rainforests, so deforestation would cause a loss of habitat for many species, and as a result, a loss of species diversity. This disrupts the overall ecosystem and has many follow-on effects. For example, nearby communities who have relied on a specific plant for medicine will no longer have access to it. The absence of trees also will adversely affect the surrounding area. The roots of trees keep the soil in place, and the absence of them will result in the soil being washed away. This soil erosion has many poor impacts on the surrounding area, such as an overall poorer water quality. Deforestation also plays a role in contributing to climate change. It is because the trees absorb carbon dioxide and release oxygen to the atmosphere. However, since there's a large amount of trees cut in tropical rainforests, the trees disappear and then the carbon dioxide just stays in the atmosphere. Remote sensing will play a crucial role for the future of monitoring deforestation. This is the satellite image of two tropical rainforests. One is from Malaysia and the other one is from Guatemala. These pictures show that as time goes on, the effects of deforestation are apparent from the loss of the green area. We will discuss satellite imagery later in the video. Another method used for monitoring forestry is LiDAR. LiDAR stands for Light Detection and Sensing, and is considered to be an active form of remote sensing. This method can also be used globally and locally. In this case, we use LiDAR to examine carbon levels of tropical rainforests. This is due to the fact that deforestation facilitates the level of carbon dioxide increasing. Thus, we use LiDAR to determine the biomass of carbon in the particular area or in the earth. We can know which areas have the most serious rate of deforestation. Satellite imagery. Satellite images can be a useful tool for monitoring rates of deforestation and for examining the effects of vegetation removal. Images are collected by satellites that are constantly in orbit around the Earth and are then licensed to companies for use in various fields. Images are taken and can be digitally stitched together to provide a broad illustration of what is happening at the surface of the Earth. The Landsat series of satellites performs the exact task, collecting images regularly since 1972. There have now been 8 satellites within this time frame, with Landsat 5 and 7 being used regularly for monitoring deforestation. Satellite imagery can contain data gathered from various spectra, ranging from visible light wavelengths through to infrared and ultraviolet. Radio meters on board Landsat satellites are designed to capture certain wavelengths of light. The shortest wavelength on the spectrum are ultraviolet light at less than 0.4 micrometers. Visible light ranges from 0.4 to 0.7 micrometers, and anything above 0.7 are infrared light wavelengths. Satellite imagery is made by 3 main types of resolution: spatial, spectral, and temporal. Spatial resolution is the pixel size of an image, representing the size of a surface area on the ground. Pixel size is determined by the instantaneous field of view of the sensors, determined by the angle covered by a single detector element in the sensor. Spectral resolution is determined by the interval size and the number of intervals of the wavelengths that the sensor is detecting. Temporal resolution is the amount of time between images taken of a surface area on Earth, or whichever planet is being researched. These 3 resolution factors together determine the clarity and accuracy of a satellite image. Increasing any of these factors will increase the cost of the image data, so for broad-scale projects like mapping tropical forests clearing, it is more financially viable to use a lesser quality image. Landsat 7 has spatial resolutions ranging from 15 to 60 meters, 8 spectral bands, and a temporal resolution of 16 days. Landsat 4 and 5 contain a thematic mapper, an Earth-observing sensor designed to achieve sharper spectral separation and a higher image resolution. Landsat 7 contains an enhanced thematic mapper plus, a spectral scanning radiometer of 8 spectral band capabilities, which has an instantaneous field of view of 30 by 30 meters for bands 1 to 5 and 7. Band 6 has an instantaneous field of view of 60 by 60 meters, and Band 8 has an instantaneous field of view of 15 by 15 meters. This is a vast improvement over the outdated thematic mapper on Landsat 4 and 5. Enhanced thematic mapper plus on Landsat 7 has an image size of 183 by 170 kilometers. The North American Space Agency conducts extensive research on the rate and effect of tropical deforestation. Utilizing the high-resolution Landsat imagery, they can access the levels of deforestation over periods of time. They have been monitoring since the 1970s. NASA has compiled many detailed maps and spatial diagrams that interpret the extent of deforestation in tropical regions thanks to Landsat imagery. Landsat data has also been used by some government authorities to pinpoint land clearing on private land, which may have flown under the radar in previous years. In 2003, the Brazilian state of Mato Grosso introduced a timber license system that was a great success. Property maps were overlaid and compared to Landsat imagery to document and find those who exceeded the timber license limit. With tropical deforestation being such a widespread issue globally, remote sensing has its place as an effective method to monitor changes. Satellite imagery can tell a detailed story over time about the scale of a forest. This image was created by NASA. It shows the advancement of deforestation in Tierras Bajas, Bolivia. Dating back to 1917, it can give an accurate portrayal of progressive forest clearing for decades. With a spatial resolution as good as 15 by 15 meters, the image data used to create this map can detect extremely minor changes in vegetation ground cover. Unfortunately, deforestation will continue to occur throughout the world for the reasons listed previously. The world is currently experiencing a problem concerning the exponential rate of human population growth, and thus there will be a greater need for land in the future. However, the technology will continue to develop, allowing for faster and more accurate data. A satellite that will be launched in 2021 called Biomass has been designed to map carbon biomass to high degrees of accuracy on a global scale. It will be able to process and deliver data estimates on shorter timescales, instead of years like old satellite programs have done in the past. With this information, we can more accurately bring attention to local government, non-government organizations, and world organizations about this issue. Furthermore, with more accurate data to work with, illegal logging and mining operations can be located and halted to prevent deforestation, as well as monitor effects to counter deforestation, such as the growth of newly planted trees.